Hi, and welcome to Building an App that Connects to Devices. Could I please see a show of hands of how many app developers there are in the room? How about folks who develop hardware? How about folks who are just shy? Well, as both a former hardware and software developer, this is a topic that's near and dear to my heart and an audience I can relate to. Dean, who you'll meet later today,
hey guys,
and I are program managers in the Windows Devices and Networking team. And today, we're going to cover enhancements in Windows 8.1 for how apps connect with devices. These devices can connect internally inside a PC or externally. And our telemetry data tells us that over 500,000 unique externally connected devices have been connected to systems running Windows 8 so far. End users love the broad variety and selection of devices and apps for Windows. So let's start by taking a look at some of these enhancements through the eyes of end users. Meet the Ramirez family. Will, who's an architect, his wife Sarah, a real estate agent, and Toby, their teenage son. And let's take a look at a day in their life a year from today. After dinner, Toby and Will are talking about this new cool toy that one of Toby's friends has at school that launches foam missiles. Toby's just captivated by it, and he's just got to have it. Will grabs his tablet, goes to an online store, searches for it, adds it to the cart, and buys it using his fingerprint instead of a password. Next, Will goes into his home office to get ready for work tomorrow. He sits down at his desk, at his desktop, and connects to the office, starts downloading a 3D model of a home design for a customer site visit tomorrow, and starts printing it overnight on a 3D printer for a site visit. Finally, he goes to his to-do app and updates the agenda, and then goes to sleep. The next morning, Will grabs his tablet and the 3D printout and heads to his customer site visit. Upon arrival at the customer site visit, his tablet shows a reminder of the agenda based on the location. At lunchtime, Sarah goes for a run with her pedometer attached. She comes home, she connects it to her laptop, and uploads her step count to show that she's been following through on her New Year's resolution. After school, Toby comes home, sees a new cardboard box sitting on the front porch, rips it apart, runs inside, connects the USB port to his laptop, and sees a recommended app that he uses to start controlling his smart toy. Everything that Will, Sarah, and Toby do, they do with an app that connects to the rich Windows ecosystem of devices on a desktop, a laptop, or a tablet running Windows 8.1. Whether you're an app developer or make innovative peripherals, Windows 8.1 provides you new opportunities to make money building compelling products that users like this modern connected family value when they're working or playing. Since the first Build conference in 2011, I've heard a fair amount of feedback from developers like you in the audience about device access in the Windows runtime. We heard feedback like, some of you would like to be able to develop apps to scan barcodes, or develop apps for health and fitness devices that ran on ARM-based tablets running Windows RT. And some of you hardware developers would love to be able to develop an app for your device without needing Visual Studio Pro. We heard you. Windows 8.1 includes many enhancements that address feedback just like that. These enhancements effectively form the agenda for our talk. Fundamentally, we've added support and new APIs for apps to access more types of devices and added new user experiences for some of those devices. Secondarily, we've simplified your life as developers developing those apps. Let's first look at expanding access to devices. we've added new APIs for store apps to access devices in Windows 8.1. You remember Will Ramirez? Will made an online purchase using his fingerprint instead of a password. And he printed a 3D model on a 3D printer. And his to-do app used a geofence to key off of a location to show a reminder. We've added 6 new APIs for specific scenarios in Windows 8.1, and we call these device scenario APIs. These APIs leverage Windows knowledge of those devices to simplify development for specific scenarios. Now, in Windows 8.1, apps can do the following. They can use fingerprints instead of passwords to authenticate users for online purchases. They can scan barcodes and read magnetic stripes to complete point-of-sale transactions. They can use a geofence, which is effectively a radius or perimeter around a location, and trigger based upon entry or exit of that radius, like a locations-based reminders app that might remind you of your shopping list when you get to the grocery store. Now apps can manage virtual smart cards that are used for two-factor authentication in remote access scenarios. And advanced developers can develop apps that print to a 3D printer. Finally, apps can scan documents and images using scanners to go from analog to digital. These are the new device-specific scenario APIs we've added in Windows 8.1. I have a question for some of you folks. How many of you folks have already gone to the SDK sample gallery so far for Windows 8.1? Have any of you gone yet? Well, when you do go, you'll notice that there are 6. Not only do we have new APIs for these, and of course we've got documentation for them, but we've also got 6 different SDK samples to go through all of these to get you started. So that's great. But what about Toby's Smart Toy or Sarah's pedometer? These are both examples of what we call custom devices. These are devices that Windows really doesn't know much about. Unlike a scanner or a barcode scanner, where the hardware's fairly standardized and there's specific commands to scan an image or read a barcode, each of these custom devices has unique commands. We're seeing lots and lots of innovative devices shipping in volume in retail. For example, pedometers. The last time I was in Best Buy, it was really encouraging to see an entire row devoted to health and fitness devices. There's also been this long-standing community of creative, independent hardware developers making, prototyping, tinkering, hacking, and even selling hardware. Whether you're prototyping a new cool idea or selling innovative devices in volume at retail, Windows 8.1 enables low-cost store app development for custom devices by providing APIs for familiar industry standards like Bluetooth and USB on all our form factors and CPUs, like tablets based on ARM processors running Windows RT. We've added new Windows runtime APIs for the following industry standards that many Windows developers are already familiar with, like Bluetooth RF COM, Bluetooth Smart, Human Interface Device, or HID, USB, and Wi-Fi Direct. We call these device protocol APIs as apps communicate with custom devices using a protocol for that custom device. An example would be like this missile launcher you see illustrated here. An app for that device would communicate using these APIs using a command protocol for it. That device has unique commands to rotate to the left, rotate to the right, and launch a missile. And anybody who knows that protocol for that device can develop an app for it. For those of you who raised your hands when you were to indicate you were hardware developers, here's a few points about these. We encourage you to do your differentiation and innovation for custom devices as a protocol on top of these APIs and leveraging Microsoft class drivers to do so. And if you want to enable what we call an ecosystem of apps for your custom device, effectively letting your user choose the best app for your device. You can effectively create your own SDK by publishing that protocol to enable those app developers. If your custom device is a complex one, we encourage you to simplify app development by developing a Windows Runtime Component DLL that effectively wraps that protocol and simplifies app development. How many of you folks saw the keynote this morning? These new APIs effectively enable innovative devices like the Lego Mindstorms that Antoine showed during the keynote. They also enable the app for Sarah's pedometer and Toby's missile launcher. And they're also really approachable for the set of independent developers who are prototyping new cool devices. I wish we had something like this when I was learning about hardware. Instead of using like a hex editor and a debugger, how cool would it have been to be able to prototype a device using an app written in only JavaScript and HTML? And finally, you can enable an ecosystem of apps for your devices by just publishing the protocol. These APIs enable all these scenarios. And we also provide 7 new SDK samples to go along with these APIs that you all have access to now, today. So to kind of recap, when you're developing and designing your apps, always look first for device scenario APIs because they leverage Windows knowledge of those devices to simplify app development. Secondarily, look for device protocol APIs for custom devices. And together, these two families of APIs are how Windows 8.1 expands access to devices. As I said, not only did we expand access to devices, but we added some new user experiences. When we were planning Windows 8.1, we studied many apps for custom devices. And what we found was that they typically launched when a user connected them by USB. They often sync data locally to and from a device, and then increasingly to the cloud. And finally, many of them, particularly apps for health and fitness devices, tended to involve some privacy-sensitive information like blood pressure, as an example. So let's first take a look at Launch on Connect. Autoplay launches a recommended app when a USB peripheral is connected. What a user will see is a toast like you see in the upper right-hand corner that the user can click on to launch a recommended app. This is really useful for custom devices that Windows doesn't know anything about and obviously doesn't have any built-in user experiences. Launch on Connect helps a user discover the best app to use with a custom device. To enable it, hardware manufacturers first must opt into autoplay for their device. After that point, any software developer can enable autoplay in a few straightforward steps, like adding an autoplay activation routine, which gets invoked when the user clicks on that toast. And our custom USB device sample actually includes code for enabling autoplay, so I encourage you to take a look at that. As I said, many apps tend to increasingly sync data to and from a device. So device background tasks in Windows 8.1 lets an app complete a sync operation that a user initiates in the foreground for up to 10 minutes in the background while saving system battery life. Any app can include a background task which keys off of a new trigger we added in Windows 8.1 to enable this scenario. Once the task starts running, the user will be prompted with a consent prompt like you see here, and once they consent, the task can continue running. We've primarily focused on the USB and the HID APIs for this scenario, and one common form of syncing data with device is for hardware manufacturers to update firmware for externally connected devices. Hardware developers can also enable firmware update for their devices using a background task. As I said, custom devices are devices that Windows really doesn't know much about. So we actually treat custom devices much like a privacy-sensitive device, like a webcam or location. And we put the user in control before the app can potentially access privacy-sensitive information, like your heart rate or anything like that. Windows provides 3 user experiences to put the user in control. The first one is a consent prompt, like you see in the middle of the screen, where the user can either allow or block access to an app the first time the app goes to access the device. The second user experience is while the app is running, they can go to the settings charm and the privacy there, and they can actually revoke access to the device while the app is running. For example, if they made a choice that they don't like, they want to change their mind. And the third user experience around user consent is before a user goes to download an app from the store in the store product description. They'll see information there that helps them make an informed user consent choice before downloading that app. Any app that uses the new Bluetooth, HID, or USB APIs, in addition to using those APIs, must make device capability declarations in the app manifest. And Windows does the rest. One thing that you should handle in your app, however, is because the user can change their mind and revoke access, you should handle access status change notifications in your app. So, those are the 3 new user experiences we've added for custom devices. Launch on Connect, syncing data in the background, and user consent. Together, the new APIs that I've mentioned, as well as these new user experiences, are the new whats that we are providing in Windows 8.1 to help you build compelling products for end users. And I personally can't wait to see what you folks come up with based upon this. The fun part about building a platform isn't building the platform, it's seeing what people build upon it. Next, I'd like to introduce Dean, who's going to walk you through how to actually build an app to do so.
Thanks, George. My name is Dean King-Smith. I'm a program manager in the devices and networking team, and my passion is around the developer experience. We've seen a little bit about the what, so let's talk about the how. So as I saw earlier, I think a few people up here were software developers, and I saw a few hardware developers maybe in the backside of the room. Whether you're a software developer or a hardware developer, Windows 8.1 has simplified that development experience, enabling you, the software developer, to connect to a device, and enabling the hardware developer to enable access for that device. Let's talk about what some of those options are. First and foremost are the scenario APIs. These are by far the easiest way to connect to a device. If you've ever written an app for Windows, you already know how to do this. Just simply use the namespace and the API, and Windows does the rest. Next up are the device protocol APIs. These are brand new for Windows 8.1 and enable you, as George mentioned, to use familiar industry standard protocols such as USB, HID, Bluetooth, and others to connect to your device, provided you know the specific protocol for that device. And the other cool thing about the protocol API is that for a hardware developer, it enables you to create an ecosystem of apps by taking that specific protocol for that device, wrapping it in a Windows runtime component, making it available to the software developer. Oh, and the best part about all of this is that it can all be done, click, there we go, from within Visual Studio Express 2013. So let's take a moment and dive a little bit deeper into each of these 3 areas, starting with our scenario APIs. As I mentioned, this is the same as pretty much the same experience as in Windows 8. Simply use the namespace and the API, Windows does the rest. Some of these scenarios include fingerprint, geofencing, and more, scanning as well. And to be successful, all you need to know is how to develop an app and the actual API that you want to call. Great example here, George mentioned our scanner sample, or one of our new APIs for Windows 8. This is actually a snippet from one of our samples. Key thing to point out is what's in red. Using that image scanner class, I can create a MyScanner object, and as soon as I have that object, I have access to the wide breadth of API calls, in this case, scan files to folder, to start scanning. Next up are device protocol APIs. Again, this is something that's brand new for Windows 8.1 and something that I'm personally excited about. These APIs simplify access to custom devices using these familiar industry standards, again, provided you know the protocol. Some of these scenarios include a sports watch, Toby's missile launcher, or realistically any custom device that takes advantage of these standard protocols to connect, and that you know the specific protocol for the device to control it. To be successful, you need to know the protocol and the industry standard protocol to connect to it, and the one for the device. Now, as much of a fan of slides I am, as I said, I'm more passionate about the developer experience, so I'd rather switch into VS to show you code and do a demo. But before I do that, you got a little something to demo with. Can anybody guess what it is? Who peeked? Toby's missile launcher, of course. And here it is. We have the V1 version, the V2's on the screen. Now, the beautiful thing about this is that realistically, it took us under an hour to develop this app, but took us about 3 hours to test it out. And by testing, meaning chasing all the little rockets as we launched them around the office. So let me fire up my laptop with SwiftShoulder Visual Studio. We'll take a look at the app that we built to control this rocket launcher, and also take a look at some of the code that controls it. Excuse me? So the question was, is it the same app that's available in the big room right now? And the underlying code is the same, but we just tweaked the UI a little bit. So switch over to VS. I'll walk you through the code in a second, but there's no point in building an app if you can't actually play around with it. So the first thing you see, this is our really simple missile launcher app. We'll start it up, and you'll notice that that device consent prompt pops up. So the user has control of what the app's doing with the device. Hit allow, and at that point, I can move to the right, move to the left, and I need a target. George, can you come over here? Nah, don't worry about it. I don't want to shoot George. I got to work with him on Monday. So there we go. As you can see, using the familiar device protocols, excuse me. Yeah, there we go. Using these familiar industry standard protocols, we built a really simple app in under an hour to control this device. So let's take a look at the code that controls that. As I mentioned, with the device protocol API, you need to know the protocol specific for this device. In our case, this device uses HID over USB to actually connect and control. We took some of the guidance from the hardware reference doc we received from the manufacturer and actually put it in as comments in the code. You can see, for example, to move it all the way up or all the way down, you effectively just send a byte. To fire, it's 0x10. This is something, these commands are, again, specific for that device. And when it comes to actually mapping the buttons that I just showed you back to a command, let's take a look at right-click. Using right-click, we built out a function called send command that takes advantage of the protocol specific for that device and pass it the byte. Now, we talked a lot about enabling an ecosystem of apps. So let's take a moment and take a little bit of time and talk about what that looks like. As a hardware developer, you can provide this Windows runtime component to enable this ecosystem of apps. What that's effectively doing is creating your own custom SDK by taking this protocol specific for that device and wrapping it in a piece of code that you can easily distribute to a software developer. The great thing about this is that it reduces the complexity that your software developer will have to go through in order to connect and take advantage of your device. Some of these scenarios include Sarah's fitness device. You can imagine a scenario where Sarah got home, cracked open her fitness device, connected to her Windows 8.1 system, tablet, desktop, or otherwise, and had a choice of which device to use based on the ecosystem that the hardware developer has enabled. To be successful here, what you need to know for a hardware developer is, again, the specific protocol for that device. And for the app developer, you need to know, A, where to get the Windows runtime component that exposes that protocol, and also how to use it in the app. So let's take a look at some code and actually take a look at what that looks like, and let me walk you through the process. So we'll stop debugging on the old version of the app and switch over to our runtime component. Right. This template that you see right here is actually a template that's available in Visual Studio. So in order to build a runtime component, you already have the base set of tools and framework that you need. In our case, what we did is took that send command and embedded it in a missile launcher device class, and took those same functions that were previously in the code and exposed them as a fire function, a stop function, which still leverages the exact same send command code, but is now wrapped up in a Windows runtime component. So to add it, we simply statically link the reference, the component. And then when we take a look at the object browser, we now have the same simple commands we used in the previous app exposed as part of this runtime component: left, right, up, down, fire, stop. For the actual application, key things to remember: include the component, small details. And then once you've actually included the component, you can create an instance of that class, in this case, Missile Launcher. So let's take a look at that same right-click call and see what's different. You'll notice, instead of having to worry about knowing send command, instead of having to write send command and then know what bytes you need to send to it, now the software developer can simply just say, hey, let me use this Missile Launcher object that I just created, missile launcher.up, or missile launcher.left, or in this case, missile launcher.right. You can imagine a more complex scenario, or device where a Windows runtime component can dramatically simplify what the software developer has to worry about in order to take advantage of that device. And since no code is good without actually running it and taking it for a spin, let's fire our last rocket. There we go. This is developing for Windows 8.1. Whether you're doing a scenario API, using our new device protocol APIs, or enabling an ecosystem of apps via the creation of a Windows runtime component, we simplify that developer experience. Now let's talk about what a hardware developer can do to differentiate that user experience. For the hardware developers in the room who've ever developed hardware for Windows before, they might be familiar with something called device metadata. In Windows 8.1, you can continue to use device metadata to differentiate your user experience. For those who are not familiar with device metadata is, if you've ever looked in devices and printers and wondered where that pseudo photorealistic icon came from, in this case, our document writer, that actually comes from device metadata. Scenarios that this enables are autoplay, which we talked about earlier, automatic installation, and a couple other ones like device syncing and firmware updates in the background. To be successful here, there are a couple things you need to know. Since this is more of a hardware developer focused functionality, you need to know the hardware ID. This is what links your device metadata to the actual hardware. You also need to know how to submit your hardware to the Windows Hardware Developer Dashboard. Device metadata development and app development are actually two completely different processes, but they do complement each other, and I'll walk through that in a little bit more detail momentarily. You need to know your app information. You need to be able to link your app to the actual device metadata package. And last but not least, how to author device metadata. Now, one of the things about authoring and developing device metadata, we got a lot of feedback from Windows 8 and also Windows 7. We looked at a lot of telemetry data on the success rate of submission of metadata packets to SysDev. And with that information, we actually made a few improvements into the experience. So, quick show of hands. Has anybody actually developed device metadata before? Yes. For the few people that did raise their hands, this looks brand new to you. This is our new device metadata authoring tool for Windows 8.1. Three key things that we made direct improvements on. First and foremost, the most obvious one, you now have a validate metadata functionality. And I'll touch on that in a second. But to start, to make it easier for you as you're walking through the metadata development process, the experience is now pivoted around 4 key scenarios. And the tool would actually dynamically change what it checks and what it displays to you based on those scenarios. Second of all, we noticed that a lot of little minor errors were being made as you were made in the package that were submitted because of typos. So we built in check validation functionality actually at author time while you're creating your package. And the last one, which I touched on briefly earlier, since you're now creating a metadata package for the device, you're taking your hardware and testing your app. We want to make sure that you can test all three of those components and make sure they're glued together properly offline. So let's take a look at what that looks like. So I'll tap new device metadata, and again, as I mentioned, it's scenario-based. So up top, we have building metadata for Windows Store device apps, for a device by itself, which is supporting legacy functionality, whether it's an internal device targeted primarily at OEMs for devices that ship in the plastic, or a mobile broadband device. These are our 4 key scenarios. Tapping Windows Store device app metadata, you'll immediately see on the left all the different steps that you'll go through for creating this metadata package. I want you to pay attention to app info for a second. As I switch to device-only metadata, tap, there we go, you notice app info disappears. This is a simple example of the tool taking your intent and optimizing the entire rest of the workflow based on that. So let's cancel out of here and take a look at some of the validation functionality. Made a simple metadata package last week. Really bad icon. But this is a quick example of what the summary page looks like when you edit any metadata package. Shows a quick summary of everything you entered and what the validation check value is on any of the steps. Taking a quick look at hardware info, let's go ahead and remove the hardware info. You'll notice as soon as I remove it, the tool actually will prevent me from moving forward because that hardware ID information is something that's critical to link the actual device to the metadata package. We'll add some garbage back in. I know this isn't right. You guys know this isn't right, but the tool doesn't. So how do we check for that? This is where that third improvement and enhancement comes into play. Tap on validate metadata, and now you have the ability to take that metadata package and check it against your application, check it against your device, or check it against your application and device. And once you actually run that, you'll get presented with a report that looks like this. Now, what you see here are a list of tests that we've run based on what you're comparing, whether it's package, whether it's metadata and app, or metadata app and device. These tests were chosen based on a lot of the common failures we saw. For some of the tests that did fail, for example, experience ID, you notice there's additional contextual information around that, which will tell you what the issue is that caused this test to fail, what data that caused the issue that caused the test to fail, a recommendation on how to fix it, and if we have more contextual information online, a link to more information on MSDN. These are just 3 of the simple improvements around device metadata authoring that we feel will make it easier for you to enable new user experiences using device metadata. But as I mentioned earlier, device metadata development and app development run on different tracks. So let's take a moment and look at how the 2 of them come together. If you developed apps for Windows in the past, you know that the first thing you need to do is go reserve your app name. Once you reserve your app name, app identity information is locked in the store. Once that's done, or even in parallel, you need to submit your hardware to the developer portal. This is going to get our hardware developer portal primed to accept your device metadata. Once these 2 things are done, you can go ahead and move forward. Develop your app, develop your device metadata. A couple things to keep in mind. I mentioned there's linking between all of this stuff. So to link your app to your metadata package, first thing you need to do once you get that app information is actually simply include the app info in your metadata package. Once your metadata package is done, it'll generate something called an experience ID. Link back to the test that I just showed you. You take that experience ID and include it in your app. The tool will actually spit out a file that's simply just including your app package. Oh, and by the way, you can include this file in your app package before your app is even complete. So you can quickly bang out a quick metadata package to support your device and your app before your app's even done, and you'll still be good to go, and you can test all of this. Once that's done, submit your app to the App Store, wait for it to go live, and then submit your metadata package to our hardware developer portal. This ensures that when Sarah connects her fitness device and the autoplay options pop up or the automatic installation happens, the app's available in the store. This is great. Like, I'm excited about this because it's much better than it was in 8. But while I'm passionate around the developer experience, always have to keep in mind on what this means to the customer. And in the case of today, it's the Ramirez family. So to think about that, I actually have a question for you guys. Well, the gentleman here in the black jacket, will you be the one who builds the app that enables Toby's dad to buy his rocket launch, buy this little thing with his fingerprint? Or even my friend here with the red office shirt, I have that shirt. What's stopping you from being being the person who builds the app that Sarah uses for a pedometer? Or matter of fact, realistically, what's stopping anybody in this room from building apps that enable that 3D printer to be used directly from Windows 8.1? Or, my personal favorite, the rocket launcher. Think about that. Don't answer it yet. We'll come back to that in a second. All of these, plus the protocol access, our scenario APIs, are how Windows 8.1 has expanded access to devices. This paired with new user experiences that always put the user in control and give them awareness around what's going on. Are some of the outward enhancements. And to make all of this possible, we simplified the developer experience. Now, I ask you, what's stopping you? Realistically, the answer is nothing. You have the tools. We've enabled the API. We've made improvements that empower you to take advantage of everything we've built, to build these great experiences and build these great apps to go with these devices. Now, if I was somebody in the back of the room who I really can't see right now, and I've been listening to this talk for the last 40 minutes, what would be going through my mind is, man, I saw 3D printing at the keynote. I heard you guys have a new scenario API for it. How do I do it? Where can I find more information about this stuff? Or maybe you got super excited when you saw Toby's missile launcher and want to go home and build your own missile launcher app. How do you find out more information? Guess what? We got you covered. For scenario APIs, for example, if you're super interested in scanning, we actually have a live talk that's available, that's coming up on Friday, I believe, around the scenario APIs, around the scanning scenario APIs. And for many others, they're already online and on demand. So if you go to channel9.msn.com, you can actually go see some of these already. For the protocol APIs, for the 3D print, for example, we have a talk that's already pre-recorded and that's available right now on demand. And for those who are super interested in the protocol APIs, specifically Bluetooth, don't go anywhere. Actually, just go ahead and hang out in this room. The talk directly after this one is going to talk about Bluetooth and our protocol APIs and how to take advantage of that. This is how you can connect your app to a device in Windows 8.1. And this is just a quick sample of the improvements that we've made. And I encourage all of you to take a moment. Everything that you've seen here in these past two slides will be available online shortly after the conference, if they're not already available. And to George's point earlier, he's looking forward to see the apps you create. I'm looking forward to buy something for my version of Toby, my nephew Jonah, at Christmas time, when I can bring home a Windows 8.1 tablet. It's like, here, enjoy. Oh, and by the way, here's some nice new smart toy that you're going to have a blast with. And with that, please get feedback. I'd like to invite George back up, and we'll take a few questions.
So, what questions do you folks have?
I think I see a hand in the back
Ideally,
there.
you come to the microphone. Yes.
What's up?
So how do I develop Toby's smart toy app for an ARM platform? Is there a compiler available for that? Not for the app, for the driver.
So the beauty of that is you don't need to develop a driver for it. You can just use the app that we showed uses HID. This device uses HID.
Yep.
And using the new device protocol API for HID, you don't need to develop a driver. You leverage our built-in class drivers and you just write app-level code.
Yep.
So as long as I'm satisfied with the functionality of the class driver, I'm okay. But if I need to do anything beyond that, then I'm constrained by these
Yeah.
limitations.
So for custom devices, you can use the new device protocol APIs like Bluetooth, RFCOMM, Bluetooth Smart, HID, USB, and Wi-Fi Direct. And that's how you can do it leveraging purely R-class drivers to do so, and you don't need to develop a driver.
Cheers. Gentleman in the blue shirt.
I was just wondering, do the new profile APIs support Bluetooth Map?
Bluetooth map.
The message access profile?
That's actually a question that I'd like you to save for the session afterwards for Alec, because I'm not a Bluetooth expert and I don't even play one on TV.
Okay, that's cool. Thanks.
But do hang around.
Next question.
This question might qualify for the next session also, but will there be support for Bluetooth Low Energy?
So the question is, will there be support for Bluetooth Low Energy? And Bluetooth Smart is actually the same as Bluetooth Low Energy, so the answer is yes. The next question.
Do you guys plan on supporting MIDI or having a scenario for MIDI?
The question is, do we plan on supporting MIDI? And the simple answer is, unfortunately, we do not have an API for MIDI in Windows 8.1. It's something we looked at, and it's something we'll consider as feedback for the future. Next question, please.
Yeah, could you expand on the scenario API for geofencing and what exactly is capable there?
Sure. Well, I'll summarize the conceptual model, and I'll encourage you to go to the online talk for more details. But basically what we've done is you can declare a perimeter around a location, and then there's new background tasks that you use that get triggered upon entry within that perimeter and exit from that perimeter. And for further details, I encourage you to look at the updated location sample that you can download today, as well as the Windows.location API documentation. And if you have further questions, feel free to catch me afterwards.
Cool.
Next question.
Are there still restrictions in the number of apps that can be associated with a particular device? So you showed the process of creating device metadata and then popping out the file that you get to include in your app that associates it with the device. Is that a one-to-one thing or a one-to-many thing?
So the question is, are there still restrictions on the number of apps that you can associate with a particular device? My quick clarifying question to you, are you referring to the autoplay scenarios, or are you referring to thinking about auto installation or things along those lines?
My specific ask is more around internal devices on a platform. If you, say, had some internal hardware that you wanted to open up to a broad selection of store apps and whatnot, there had been some pretty strict restrictions around like 5 apps or something that can actually be granted access to that, or does this change at all?
So I believe the scenario you're mentioning is one for an OEM that's building, say, unique hardware inside a PC. Is that a fair summary?
Yes.
The short answer is that I encourage you to contact your Microsoft OEM representatives for further details on the OEM scenario.
Cool.
Next questions.
Yeah, I assume that devices that are claimed by class drivers can't be opened through these APIs. Is that right?
So is the question that you're asking, can I use the USB API for, say, an audio device?
Yeah.
So the answer to that question is the device protocol APIs are designed for custom devices.
Okay.
Specifically, that means that you cannot use the USB API for a USB audio class device or a USB printer class device.
So basically, if there's a class driver that Microsoft provides that you can't use these APIs for that, is that right?
Correct. They're designed for custom devices.
Are there any other limitations on what devices they can be used for, or is it essentially anything that's not already
Well,
planned?
let me summarize the basic intention, and then I'll point you to the other talks for more details.
Okay.
But basically, they're for custom devices. And we've designed them, for example, like the HID API, so that they do not interfere with built-in OS functionality. So you should not be able to use like the HID API to be able to access raw keyboard or mouse input, as an example. So if we provide APIs within a device class, like for printers or for audio, The answer is use those APIs instead. The protocol APIs are really for custom devices.
Can you call those APIs from the Windows Store app?
I'm sorry,
sorry,
what's the
can you say that
question?
again?
All those APIs from the Windows Store app?
You can use Windows Runtime APIs for like audio, for printing, or the device protocol APIs, like the HID, the Bluetooth. Yes, they're all Windows Runtime APIs. Well, if there's no further questions, we really thank your interest, appreciate you coming, and we'll be available for Q&A afterwards. Really appreciate it. And I can't wait to see what you folks come up with based upon this.